Hi everyone, welcome to our second workshop in this series. Last workshop we talked about the things that got both of us into production. We kind of went over signal flow and how we get audio and MIDI into our DAW. We went over the basics of what's happening inside of our digital audio workstation and started making some loops that are going to turn into a song. So now we're going to go over some other concepts, and then we're going to go back in and start working on the song more.
Yes. So first, we want to explain further how the signal flow works inside of the computer. So let's sketch that. When we talk about signal flow inside of the computer, first we have a clip. When we are like in MIDI world, we have a clip, and that clip is sending some kind of information to a computer. Last time we did a clip of like a bass sound, and we did a drum clip. And then further we can go to MIDI effects. MIDI effects are in some way changing that information, one of those information that we are sending to a computer. So for instance, we can change the volume of that sound, or we can change the pitch of the note. And we will show you one MIDI effect, so just for you to get an idea. Then we go to our synth. In this moment, we don't have MIDI information anymore, we have sound, because at this moment that MIDI information becomes some kind of sound. You heard like how with like bass sound, that clip sounds, you heard like how that MIDI information changed into a drum sound. And after we go to different audio effects. Today we will talk more about some of those effects. And with audio effects, well, you in a way have more control over your sound. You do some like technical stuff with some of the audio effects, or you kind of change the sound from the original synth. For example, I don't know, you can put a distortion, then you kind of change the color of that sound. And then sound goes out on master, and you can hear it in your speakers or on your headphones. Okay, so now we're gonna see how the signal flow looks in Ableton. And first, we have our synth already here. We will draw some MIDI effect, which is here. And you don't have to think about the order in a way like where the MIDI effect or where the audio effect will end up. Ableton will do that on its own. So we now have a pitch, which is a MIDI effect. And what it will do, like we have this bass in this pitch, and we're turning this up or down, we are changing pitch of that sound. So why we sometimes use MIDI effects? Because in this way it's much easier. We don't have to go to every clip, and like if we are like, okay, for instance, when Summer was recording her vocals, the first bass was kind of out of her
vocal range.
So with this, it would be much easier, because if we had like a lot of clips here, and we want to change it in the same direction, we don't have to open every clip and change it. We can just put this pitch MIDI effect here and change for all of them at the same time, for instance. Okay. Then in our signal flow we have bass, and then we go to different audio effects. For example, we can put some delay here. And now our bass will sound like this. Okay. And what is also important to say, if you like now like start to drop a lot of different effects, the order is important.
Yeah, so what you were saying earlier about order not being important is the difference between MIDI effects and audio effects. As we showed that signal flow, the computer will order that for you, but the order of audio effects one into the next will change your sound, because it's like when you're choosing your order of operations, PEMDAS in math, it's changing the order that things pass through.
Yeah, and that's also true for media effects. So yeah, that's for the signal flow inside of the computer, and then in the end this goes to master.
Okay, so last time when we were going over the channel strip in Ableton, we talked just for a moment about the send section. And there are several reasons why you would use a send, but the idea is you basically are routing signal in its chain. You have your input, and then you do all of these things to it, and then it goes out the output. So you're routing it in between the in and output, you're routing it to another place, and in this other place, you can affect it with things, and then you route it back on a return.
And show them here. Just draw it like.
So it would be here that you would be sending the audio some direction, and then you do some processing. This is processing occurring, and then you're going to return it. And you can also do a thing called parallel processing, in which you don't return it to the original chain, but you return it to the out. And those are just different ways of manipulating a sound. But the reason why you might use a send, one example is that, say you have a reverb effect, which we're going to go into detail on how that sounds, but an effect called a reverb, which is adding some space to a sound. And say you have that on a vocal, but you actually have a choir and you want it to be on a bunch of different mics, you want the same reverb, instead of putting the audio effect straight on the channel, if you send all of these vocal mics to a separate place, then you can, in this separate place, affect them at the same time with the same reverb.
Yeah, which is much easier. For example, if you want to change something on that reverb, you don't have to go to every channel and change it all over again. You just do it on that one reverb, and it is going to every vocal there is in the choir, and you're done.
It's more efficient for you, and your computer will thank you because it's much less processing power.
Yeah.
Okay, so I'm going to first cover the two most important ways to affect sound for mixing. The two things that I'm going to cover are EQ and compression, and they're important for two different reasons, but basically they are key tools. They're your most important tools for shaping sound, and we use all these visual words to describe sound because it's kind of this strange thing to not be able to see what we're talking about, but we have to imagine that there is a spectrum to what we can hear. So if you remember when we talked about the cube, one of the sides of the cube was the frequency domain, and I wrote 20 hertz at the bottom and 20 kilohertz at the top, and that's because that describes the range of human hearing, and those are the frequencies we care about. And EQ is a very important tool because it allows us to shape each sound to have a space within that domain so that they're not sitting on top of each other. So we're going to just briefly try to get you the beginning ideas of how you might play with these concepts and why they're important. And we're going to draw this out on graph form here. The spectrum that we talked about starting down here at 20 hertz, which is the lowest sound that we can hear, and up here at 20 kilohertz, which is the highest sound that humans can hear. And when we break the spectrum up so that we can communicate with each other about where things are at, we like to talk about different zones, and we call those zones bands. So these different bands, you can have a lot of ways of breaking up the bands, but there are three main ones, and that is the low, mids, and the high end. Okay, and then we're going to just talk about what typical instruments live in these different bands. So first in the low end, we have one of our most important instruments, the kick. And we have the bass. And now, why it's important to know what exists in the same bands, it's going to help you intuitively know if things are in the same area, you might have problems with them being on top of each other. And so we have to make space so that they don't cover each other up in a mix. So in the mids, we have a vocal is probably the first thing we think of. And then snare. We have guitars. We have some kinds of synths. And so the thing about this is we're talking about where the fundamental of a sound lives. So there are overtones in all these different sounds that exist in different places all across the spectrum. The vocal is never just in the mids. The kick is never just in the lows. However, the fundamental, which is, you could say, the meat of the sound, is in these different areas. With the synth, you can really have the fundamental be in the mids or in the highs, depending on where in the octave it is. And then we're also going to say hi-hats as probably your most important thing existing up top. And then cymbals, other kinds of cymbals. May. And then shaker. So all these auxiliary percussion sounds. And that's kind of our starting point. And of course, there's many other kinds of instruments. And there's, sampling things that aren't even instruments to start. But this is a good place to know where you might be having things making a mixed sound, say, muddy, where there's crossing between different zones, things kind of stepping on each other. So I'm using all these visual languages like stepping on each other, muddy. It's because, and I'm drawing out these bands. All right.
Okay, so let's hear what EQ will do to our drum loop, for instance.
So let's open up an EQ, and we're going to talk about the different types of EQ.
Yeah.
There are several different shapes we use to affect a sound with our EQ. The most classic one is the bell curve. So we're going to show this shape, and we're going to talk about the parameters that affect things. So let's pull up.
This is like one bell.
So as you can see, it gets its name for that it looks like it has the parabola kind of bell curve. And of this, there are three things we're choosing. So we're choosing the frequency, so where in this 20 hertz to 20 kilohertz spectrum we are
putting this bell.
Yes. And then we are also choosing the width of the bell. So it can be a very thin or it can be very thick. And this number that we use to determine the width of it is called the Q.
Yeah, as you can see here, Q.
And then the last thing, because right now we have a positive, we're boosting. So with EQ, you can be boosting or cutting. And so that's determined by the gain. So that's how much we're boosting or how much we're cutting. So let's take it from being a boost to a cut.
Okay.
All right.
So let's hear how that sounds. If we move this bell around, what happens to sound? Or if we are cutting some sound out. Okay, so that's how bell works.
So next we're going to talk about two different kinds of filters, and both of them have two names, but the names are kind of self-explanatory. They're both just referring to the job it's doing. So we're first going to talk about a low cut or high pass filter, and you'll see that that makes sense that it has both these names because it is cutting the lows, which means that it is also passing the highs.
And it looks like this. And now you can hear what it is doing. Okay, so as you can hear, it is cutting lows and
letting the highs pass through.
yeah.
And so then the next filter type we're going to talk about is doing the opposite of that. And that means that it is cutting the highs and letting the lows pass. So it's a high cut, low pass filter.
And it looks like this. And this is how it sounds.
And we can use filters like this as effects to really shape our tension and release when we're songwriting, because I don't know if you could really feel it from just hearing that, but when you take something away, it gives this kind of building effect that then is so satisfying when the entire spectrum returns.
Yeah, that's the most common thing that DJs do.
But
sometimes.
yeah, so this is
Yeah.
filters. And EQ is a kind of,
Yeah.
filter. But the bell curve that we were talking about is more how we shape sounds so that they do not get in each other's way.
Yeah. And we will show that in our next video.
Okay, so next up we're going to talk about compression. And I think compression is one of the more stressful but also most important. EQ and compression are the most important tools in your toolbox, but compression is a lot harder to hear at first, which I think makes it feel really daunting because it is incredibly important. But at first, I know for me and for you also,
Yeah.
you almost are like, what is it actually doing? It felt like it took a long time to grasp, but one tip I will give is that with anything like this, with EQ, with compression, with any effect, doing things to their maximum, so over compressing, just so you can really hear what it is actually doing,
Yeah.
and then backing it off to something that actually feels comfortable is a great way to start to understand how you want to artfully shape a sound. Okay, so the thing you are doing with compression is you're creating dynamic relationships. So do you want to go to, we'll draw this real quick. Okay. So when you have a waveform, it looks something like this. Okay. And that means that we have highs, such as this, and we have lows, like this. Okay? When we're compressing things, we're taking the highest highs and pushing them to be quieter, and we're taking the lowest lows and raising them to be louder. So a compressed waveform, I'm going to draw it on top of itself, would look kind of like this. So as you can see, I've taken those low lows and they have come up. The middle has been less effective, and these high points are now lower down. Okay, so why would we want to do this? Compression is important because it's dynamically shaping a sound, and that allows vocals to be way more in front of a mix, because that means that the really quiet things that a vocalist saying can get brought up, and also make it feel more even, because if they yelled and suddenly it totally jumps out, that's going to be very startling for a listener. So we have to create this smoothness across our entire piece. And so compression allows us to do that. It also allows us to have the entire mix eventually louder in the mastering process, because when we've kind of even everything out, then if you notice in what I drew with this waveform, the second waveform is it looks like the overall waveform is quieter. So then we have a thing called makeup gain, where everything can come up, and that actually ultimately results in everything being able to be louder and pushed harder. So let's go talk about, there are a lot of parameters to compression. We're gonna talk about what I think the three most important ones are.
So let's talk about compression. We'll put compression on our drums.
Okay, now we're going to talk about the most important parameters around how a compressor works. So we can start with the ratio. The ratio is the amount of compression. So how intensely is it compressing the sound? A higher ratio means that we're compressing more. A lower ratio means that we're compressing less. So how hard is the compressor working, basically? Then we are going to talk about the threshold. The threshold is the point at which we begin compressing. So by point, I mean the volume, basically. How hot is the signal coming in? When do we want it to begin compressing? Do we want it to compress even when it's quiet, or do we only want it to compress when a sound peaks? So then in many compressors, we have something called makeup gain, where we match the output gain to our input gain, because as we saw in the drawing, when we squash the dynamic range, the entire sound ends up quieter. So we want to usually put on makeup gain to bring it back up to its original volume. This has auto makeup gain, so we're just turning auto on, but many compressors you have to set your own makeup gain. Okay, so we're going to do what I was recommending, which is turn everything to its max setting. Hear how it is affecting the sound. Hear this is, we would say, an extremely squashed sound. And then we'll back it off to something that actually sounds musical.
So this is without compression, and this is with. This is terribly compressed. We'll back up the threshold.
And then we probably want to back off that ratio. So something is really important when you're first figuring out how to use these plugins is using metering to your advantage. So over here, the in between, where Ivona's mouse is right now, you can see when that pushes down, that's the compressor actually functioning. And you can see in the more artful settings, we had it really just pushing on the kick drum hits, which is just when it peaks. Whereas I don't know if you rewind and look at the less artful settings, you'll see that the compressor is on the entire time, and that sounds kind of silly.
Yeah. So let's do good compression.
Okay. Yeah, and then the other things that we can set are the attack and the release. So the attack and the release are the attack is how fast the compressor kicks in, and at the threshold point, how quickly does it begin compressing, and the release is how quickly does it let go of compressing once the sound dips below the threshold point. And the most important thing about attack and release are that the attack of a compressor is going to affect the attack of your sound. So for example, if you have a kick drum hit, you might want to make sure your attack isn't on 0 milliseconds. You want to, well, this one, it looks like it starts, so you want to turn that attack to a place where we're still getting the click of the initial hit of the kick drum, that we're letting that through, and then we're squashing down. So let's listen to how that sounds. And we probably want to give it a little more of a gentle release. There's also, as you can see, an auto setting, and I would recommend using your ears, but in the beginning, sometimes it's nice to,
auto setting.
Yeah.
Okay.
Onward.
Yeah. Now let's go to audio effects that we mentioned before, delay and reverb.
Yeah, so these are more kind of sound design, and it's not that you can't use a compressor or an EQ to do more sound design effects, but these are really meant, like, that's their only function. They don't have as much of a mechanical function. They're really more for designing the atmosphere of how everything is going to play in the piece. So we're going to talk about reverb first. So reverb is kind of this incredible magical thing we have in the digital world, because in real life, when we didn't have audio recording, you would have to build something like a beautiful church to be able to have people sing in a choir and have the room respond in a way that had a kind of a magical long decay time that sounded pleasing. And now we have sampled what is called an impulse response of all of these different spaces, and you can simulate being in different rooms. And so let's pull up a reverb.
Do you want to do it on your vocals?
Sure.
Okay, let's do it on your vocals. We put the reverb on Summer's voice, and now we will go through some of the most important parameters. There are a lot of things going on here, but for like a beginner level, I think only a few of them are important, so you can have like a general idea of what reverb does. So first we have size and decay. They're kind of quite connected, but as you can imagine, like if the size of the room is bigger, the decay will also be bigger. Like it will take longer time for the sound to go away. But what is great with digital world, you can like make rooms that kind of don't exist in the real world.
Yeah. Yeah, so you can kind of make anything that you can imagine.
Yeah.
So then we also have the dry wet, and that parameter is really just determining how much you are hearing of the sound that's going through the reverb versus how much you're hearing of the sound that is not going through the reverb. And then the last thing we're going to touch on right now is pre-delay, and pre-delay is the amount of the sound, the amount of milliseconds of your sound that you hear before it goes to the reverb. So if you make your pre-delay long enough, the reverb will sound like a delay.
Yeah, but let's first hear how the sound is changing with dry wet, and then how it's changing with manipulating size and decay. Okay, so this is completely dry sound of Summer's voice.
Trying something, trying something.
Okay, and now I will go little by little from dry to wet.
Trying something, trying something.
As you can hear also what we talked already about reverb. When the vocal becomes totally wet, it starts to feel like it's in the distance also. That's that moment that we also discussed. Let's see how it's like on 50 and with changing the decay. Now we have like 120 seconds. Now we have more, like around 8 seconds.
Trying something, trying something.
Now the decay is much longer. And then we can also see that within this plugin, we have other things that we've already talked about, such as an EQ. So we have an EQ within the plugin that can affect the sound of the reverb. So for example, we might want to cut a bunch of highs from the reverb. We probably want to cut a bunch of lows, but I think we can hear it very easily if we cut all the highs. So let's try that. All right. And then let's give them back. Then let's turn them up. Oh, you can't. Okay, you can only cut in here. Oh. And okay, size is something that it's kind of putting the reverb in the stereo image, like how big of the space it fills up. So if we go lower, it will feel more in the center in a way. Trying something. And now with like size bigger, it feels all over the place. So this is the moment that we discussed, that you can like make spaces that kind of don't exist, like make a space that is small but the decay is really long, for example. And with pre-delay, that effect that Summer already mentioned sounds like this. If the pre-delay is quite big, then you first like hear the voice kind of without the reverb, and then the reverb kicks in. Trying something, trying something. Okay, let's hear it again. Trying something, trying something. Okay. It's kind of cool that it gives it a unnatural sound, but the reason you would use pre-delay is typically not to turn it up that high, but more to let the attack of a sound through so that we maintain clarity before it goes through this nice lush reverb. Okay. So moving on to delay. So delay is basically doing a repetition of a sound. and you can control how much, like what is the time of that repetition and how much samples of that repetition you want. So let's do some kind of delay. We want to leave the original sound, so we will leave this on 50%. And let's do this kind of delay. And this sounds like this. Okay, some other different sound, like different sample of the delay. Okay, and what you can also do in this kind of delay, you can have it synced. So this will be synced on tempo. We listen to different types that are synced to tempo, or you can have time. And then you can like control the delay time in milliseconds, basically. And this is linked. So this means that you will have the same delay on left or right, or you can do different delay on left and different delay on right. Let's see an example of that. Okay,
Cool.
cool. So this is delay and reverb, and they're really important when we talk about depth, when we talk about panning stuff, and like putting more material in that cube that we mentioned the first time. Yeah. So now we went through like different audio effects. Summer talked about EQ and compressor. We talked together about reverb and delay, and now we are gonna take this more into direction of different synths. And what is there in a synth?
What is there in a synth?
Okay, so let's drag one synth here and talk more about it. So this is like a basic synth that you have in Ableton. It's called operator. And in every synth you have three parts. The first part is oscillator. And oscillator is giving a sound to your synth. So in oscillator you can find something that is called waveforms. And basically sound is made of different waveforms. And now we want to go through four basic ones. The first one is called sine, and it looks like this. Then we have one called triangle, and it looks like this. Then we have one called square, looks like this. And the last one is called sawtooth. It looks like this. It's like basically wave that is combined triangle and square. You have one like line like this and then one like this. Okay, so that is our like typical waveforms. Then this waveform that we used has to go through some kind of filter. We learned about different like filter shapes, and with like this filter we are kind of telling our synth what part of like our frequency range we want to use in that sound, and that's how we make our sound. And in the end we have something called amp. We are again amplifying our sound to a volume that we want that sound to be. So that is what you can find in every synth. Okay, so we're gonna make one sound now.
Do you want to talk about attack, decay?
Yeah, but first I want to make some kind of sound. I will just put one note here so I can hear what I'm doing. That will just go. So this is how sine wave sounds. This is how like a sawtooth sounds. This is like how square sounds. And this is how triangle sounds. So let's start with triangle. This is first oscillator that is turned on. Then I want to turn on the other one. And here I will stay with sine sound and I will add that up. Sounds like this. And then on the third one we will add square.
And by adding all these different shapes, we're creating a more complex and more interesting tone for ourselves.
Yeah. So this is
how complex and interesting.
Yeah, so we made some kind of sound here. It's kind of, this is better. It sounds kind of like a trumpet. No?
Like a little.
This is like 101 sound design. Okay, and I will now with filter try to the control part of that I want to use.
That sounds kind of like a trumpet with a mute.
Yeah, that's cool. Sad trumpet.
So sad.
Okay, now we went through what one synth has, and now we want to go through something that is kind of shaping the sound, shaping the way the sound behaves when we press some note. So now we're gonna talk about something that is called ADSR. And with these parameters, as I already mentioned, you're kind of controlling the way the sound reacts when you're pressing a note. With like sounds that we have in our like analog world, that is kind of already done for them. But in our digital world, we can decide how long of attack the sound will have, how long of the decay, sustain, and release. Those are those letters that I've written. And now we're gonna learn what that means. So, with the attack, that's the amount of time that it's needed for the sound to come to its peak. So this is an attack. Then we have something called decay, which is how much of time is needed for sound to go to its sustain level. So this is decay, and this is sustain. And sustain is basically what it means when you're like pressing a note and it's sustaining on that level. And then in the end, we have something called release, which is the amount of time it needs when you like start pressing the key for the sound to go away.
When you stop pressing the key.
Yeah, when you like let go of the key. And now we're gonna show you how that works on a sound. So I'll focus on only one oscillator because it will be easier to hear, because if I have 3 more on, then I will have to change attack on every one of them. So let's do it like this. So we will now first change the attack, like for much longer. I will put down the sustain level so you can hear the decay moment when it's dropping to sustain, and then we will also prolong the release. So our sound now sounds like this. Yes, amazing. And why is this important? When we talked about low end, we talked about kick and bass. And if you like put this note down to like a frequency of a kick and bass, with these parameters we can, like, from the same sound make some kind of bass sound and some kind of kick sound, with controlling these 4 parameters. So this would be some kind of kick. Not the best one, but it sounds like a kick. So this is some kind of kick. And if we change these 4 parameters, for instance, we sustain it more, and we put some kind of release, and go more with sustain level, now the same sound will start to sound like a bass. Amazing.
Well, and it just shows you how closely related these things are to each other.
Yeah, we didn't change the sound design. We only changed those 4 parameters.
It's the same oscillator, but just making it have a longer release and a longer sustain.
And the
Yeah. Then we've made it into a totally different instrument. And same thing with the things that we said were related in the mid range. Instead of really shaping the attack, decay, sustain, release, those affect things. But if we were to add different oscillators, we had that sound kind of sound like a trumpet. We could make it sound more like a guitar or any other instrument that's a mid-range instrument, were we to put the pitch up a little higher and then play with which oscillators are interacting.
Yeah. Cool. So I think now we should do some harmonies on our sketch. And that is your domain.
So we're going to add a lead synth or a pad.
It's up to you. We have some kind of pads here. It sounds like this.
Let's do a pad.
Okay, here you go.
And if you start deciding to try to create your own sounds from scratch, one thing that is maybe helpful is go through presets and try to describe them. So like this pad has a long attack and a long sustain.
And a long release.
And a long release. Yeah, so it has that. So then if you kind of hear these sounds and then you can describe them, then you can actually start to hear a sound in your head and then create it. So this is a pad sound. And we're going to figure out some sort of harmony to go with the piece that we're creating. So let's play it, and I'm going to mess around and try to find a good harmony.
You need only bass, yes? Or
yeah, sure. Do you want me to do a harmony or just another part?
what do you feel like it? Let's do some chords, but do you want to explain chords?
Yeah, sure.
Now you're playing. You're an inspirational moment.
No, I'm just trying to find the root note. Okay, so the way we figure out harmonies, there's a lot of music theory that can go behind it, but a lot of it is really can start from an intuitive place and just what mood are you trying to shape for your song. So, for example, there's some kind of classic patterns that we shape music around, such as a major scale or a minor scale, and those are good go-tos to think about because they sort of define whether the mood is happy or sad, which are kind of like the core characteristics. And then within that, there are a bunch of different shadings that you can add in. So we have notes, which are individual sounds. And then when we put two notes together at the same time, that creates what's called an interval. And then if we add a third or three or more notes, basically, then we start to call that a chord. And we kind of can figure out different chords that figure out different harmonies, which creates musical complexity. And
you're so smart sounding.
But basically, the thing that's incredible about using digital audio is you don't have to have a deep understanding. You saw Ivona just like drawing in with MIDI these different patterns. You don't have to necessarily know. It can be helpful to know music theory, but it's absolutely not required. And sometimes, honestly, it can make you more creative to not exactly know, have these kind of ingrained ways of thinking about where you want the melody to go. Yeah. So,
I will just stop you for a moment. I think this is a good moment just to say that we talked about synths and that we have like polyphonic ones and monophonic ones.
Yes.
Yeah.
So monophonic synths are they can only play one note at a time, so you can't create harmonies within that one kind of synth.
For instance, our bass is a monophonic.
And then polyphonic synths can play more than one note at once, and therefore they're capable of intervals and chords.
Yeah. We just wanted to mention that because sometimes you will like have a monophonic kind of sound, and then you're trying to press three notes, and you're like kind of confused
why you can't. Yeah.
Why you don't hear a chord? That is probably because that is a monophonic synth.
Yeah.
So just so you don't know what's going on if you're like starting to press more than one note and you have only one sound coming out. Yeah.
Okay. So typically a core way of building chords is stacking thirds. And we have I'm just gonna. I talked about the sort of the very basic emotions that we are conjuring would be.
Let's do this. Sorry,
I can't move my hand or I'll lose my chord.
I just put a regular piano because it will be much easier for people to hear what you're doing. Okay.
Yes.
So this is... Wait.
Okay. So we talked about how these base emotions we're conjuring are based, you can shade them in many different ways, but they're based on this happy or sad, major or minor, and that's stacking thirds. So these third is an interval, and if you put two thirds on top of each other, we create a major chord, happy, and then here's a minor chord, sad.
And that is everything.
And that's basically everything. Okay.
But we are talking about this because, well, basically with like different pads and like chords in background, you're kind of making an atmosphere for your main other parts. So that is why it's really important to think about chords and, well, because, for instance, I don't know musical theory, so what I do with like making an atmosphere, I think about the sound design, about like how that sound feels to me, and that is kind of my way to build an atmosphere. But also you can do that if you know harmony with like as you already mentioned, with different chords.
So for me, I would often go to a third to that's kind of the easiest go-to harmony. So the bass line that we have goes it's something. What is it? Wait, play it again.
Let's go. Okay, just restart.
I think that's it. Okay, here.
Here's the bass line.
Oh, okay. Great. Okay, so the bass line we have sounds like this. So if I play that a third up, it sounds like this. Okay, so let's make that a pad sound again and see if it sounds nice together. Can we make this have a slightly faster attack?
Wait.
So now we're shaping this sound because the attack was a little long for me, and I felt like it kind of took too long to come in. Okay. Okay, let's record this. And actually, let's put it up an octave so that we leave room, because I know that we have that vocal sampled sound, and that's kind of very mid-range. So we talked about how synths can really be in the mid-range, they can be kind of higher. So I kind of feel like because I know that we already in the arrangement of this are going to have the vocals taking up some of that middle space. If we put this up an octave, there'll be a little bit less stepping on each other's sonic toes.
Sonic toes, amazing. Okay, are you ready for recording?
Yes.
Wait, no. Yay! Now the drums. New hit song of ours.
The happiest sounding song we've ever made. Neither of us make happy sounding songs.
Because we are sad. That's not true.
Next time we're going to take all of these pieces that we put together slowly, and we're going to start arranging them into an actual song together.
Yeah.
And through that, we're going to explore actually practically using these effects that we went through. We're going to explore how we build a song and how we create tension and release.
Yeah, some arrangement decisions. And we are going to talk about automation. And that's that for today's session. Thank you for listening. I don't know. I kind of okay. Now we don't have time for that philosophical discussion about
Whether we are or are not sad.
not that one. But okay.
Okay, so we're totally not sad. Join us next time. Join these two very mentally well people next time. Okay, you wrap.
Stay with us for the next session next time.